Okay, so we're going to run through this real some of these related rate problems. It says you're under contract to design a storage bin. Oh, actually, these are mixed problems, so we're not sure what until we start. So you're under contract to design a storage building with a square base and a volume of 14,000 cubic feet. The cost of materials of da-da-da. Read the final question. It says find the dimensions that minimize the cost of materials. So minimize is the dead giveaway. That means we're trying to optimize this. So we need to find the dimensions that minimize the cost of materials. So what we're building here is basically a box. The building is a box. And so, and it says that it's a square base, which means we can call this x and that x. And then we just need a different variable for the height, like h. And so as you read through this thing, the cost of the materials is 4 per square foot. Oh, we need to minimize cost. So if we do a big cost equation, so the $4 per square foot, that would be 4 times the square footage of the floor, which would be x squared, so that would be 4x squared for the cost of the floor. $16 per square foot for the walls. Well, the 4 walls would be x by h, so that would be plus 16 because of that, times 4xh. And then finally, $3 per square foot for the roof. The roof would also be x squared, so that would be plus 3x squared. Now, of course, we don't want that extra h in there because that's going to have some variables that we don't want. And we can combine the 4x squared and 3x squared. But before we do that, we know that the volume of this box is 14,000. And to find the volume, you go length times width times height. So that would be is equal to x squared h. So that means that 14,000 divided by x squared is equal to h. So then my c is going to be 3 and the 4 add together give me 7x squared plus, that was 16 times that, right? So that would be 64x times 1400 over x squared. So let's simplify this a little bit more. C is equal to, that would be 7x squared. And what's 16 times 1400? times 16. So that would be plus 22,400. The x's cancel out, leaving just one x on the bottom. So finally, we've got an equation that we can take the derivative of and set it equal to 0. So let's see, the derivative of that would be 14x minus 22,400 over x squared. Set that equal to 0. And I get negative 14x is equal to negative 22,400 over x squared. So if I multiply both sides by x squared, we get negative 14x cubed is equal to negative 22,400. Okay, so here we divide by negative 14 and we get x cubed is equal to 1600. And then we take the cube root of both sides and we get 1600 raised to the 1 divided by 3 power. And we get approximately 11.70. And that would be feet. So this is what are the dimensions? That would be 11.7 by 11.7 by And let's see, 1400 divided by 11.7 squared. That'd be 10.23. Okay, this one says a total of 2,000 square feet, blah, 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 blah. Read the last sentence. It says find the dimensions x and y that minimize the cost of the construction. Again, minimize, that's an optimization question. So the whole thing is brick around the outside and then chain link in the middle. And the brick costs $10 per linear foot, and the chain link costs $5 per square foot. So we're trying to minimize cost. So if we call this x and that y, that means that my cost is going to be equal to 10x because of this, plus 5x because of that, plus 10x because of that, plus 10y because of that, plus 10y because of that. So we got c equals, say 10, 15, so that'd be 25x plus 20y. But then we also know that the square footage is 2,000, so that means that y is equal to 2,000 divided by x. So that means this is equal to 25x plus, let's see, so that would be 40,000 divided by x, because we're just plugging in 2,000 over x in for y there. So then we can take the derivative. C prime is equal to 25 minus 40,000 over x squared. Set it equal to 0. And we would get, if we move 25 over there and multiply by x squared, we get 40,000 is equal to 25x squared. Divide 40,000 by 25, and we get 1,600 is equal to x squared, which means x is equal to 40. So if x is equal to 40, that means see, 2,000 divided by 40 be 50. So the construction, the x would be 40 and the y would be 50. Okay, number 3 says two cars start at the same point. One travels south at 60 kilometers per hour and the other travels west at 25 kilometers per hour. At what rate? Aha, there's the dead giveaway. We're talking about related rates now. Is the distance between them increasing 2 hours later? So let's draw a picture. Here's my cars speeding away from each other. And the one going south is going 60 miles per hour, so we'll call that y, and this one x. So now remember, my y represents the distance the car has traveled, and the x represents the distance the car has traveled. So it has nothing to do with speed, it's distance they've traveled. And then the distance I'm looking for would be this distance right here, d. Okay? So we somehow, and this 60 kilometers, let's see, it travels south. So dy dt would be 60 kilometers per hour, and dx dt would be equal to 25 kilometers per hour, right? And we're looking for, 2 hours later, we're looking for d dt. So 2 hours later, I put that in the icebox, we're looking for d dt. So 2 hours later, y would be equal to 120, because we're going 60 kilometers per hour times 2 hours. X would be 50, and therefore if we use Pythagorean theorem, we find out that d is 130. So let's write our equation. There's an obvious Pythagorean theorem here, so x squared plus y squared is equal to d squared. Take the derivative both sides, we get 2x dx dt plus 2y dy dt is equal to 2d dd dt. Okay, so let's see if we plug in everything we know. Plug 50 in for x, that would be 100. Dx dt was 25. Y is 120, so 2 times 120 would be 240. Dy dt is 60. And d is 130, so that'd be 260 dd dt. So we got 2500 plus 240 times 60. So that would be 16,900 equal to 260 dd dt. So we divide that by 260, and we get 65 is equal to dd dt. So the distance is accreting at 65 kilometers per hour. Okay? So efficiency study, the first shift from 8 a.m. to 5 p.m. at a certain factory indicates that an average worker who arrives on the job at 8 a.m. will have assembled. So this is, you can plug in the hours after 8 a.m. and that'll spit out how many transistors radios have been constructed. So it says at what time during the shift is the worker performing most efficiently? So most efficiently, that sounds like what? That sounds like optimization, doesn't it? So we're going to take Q of T is equal to negative T cubed plus 6T squared plus 15T. And we're going to take the derivative of that. Q prime is equal to negative 3t squared plus 12t plus 15. Set that equals 0, divide everything by negative 3, that would give me t squared minus 4t minus 5 is equal to 0. I think that'll factor into 0 and t, and that would give me probably 5 and 1, where 5 is negative and t is positive. So that would mean t is equal to negative 1 or 5. Negative 1 would be before the shift starts, so that doesn't make any sense. So 5 would be, must be the high point. So what time during the shift? That would be 5 after 8, so that would be 1 o'clock. Okay. Number 5, two straight highways are perpendicular. A motorist traveling south on one of them, let's go to the end. After how many hours will they be closest to each other? Aha. So that's an optimization problem, and we're looking for the distance between them. So let's make sure we figure out what they're doing. A motorist traveling south, so someone's going south on one of them. Okay, motorist traveling south on one of them at 48 miles per hour passes through the intersection. At the same instant, a motorist traveling west on the other highway at 36 miles per hour is 50 miles east of the intersection. So this guy starts 50 miles east and then goes like that. Okay? So when he starts there, when the south going motorist passes here, the other guy's right here. Okay? And then goes 36 miles per hour. After how many hours will they be closest to each other? So then we need to figure out a minimum of d. So let's call this x and this y, and we want to minimize d. Okay? Two straight highways are perpendicular. Motors traveling south on one of them at 48 miles per hour across the intersection at the same time. Incident motors traveling west on the other highway at 36 miles per hour is 50 miles east of the intersection. After how many hours will they be closest to each other? West. Okay, I realize I read that completely wrong. It says he starts out 50 miles east of the intersection and is going west. So he actually starts out here 50 miles east and he's going west. And so the variable we're going to use actually is the time. That's really the only thing that's changing rather than distance, because we can calculate distance some other way. And this d right here is what I want. This distance actually is what I want to calculate, right? So I'm going to let x equal the number of hours. Okay? So what we can do here is, we know if this whole thing is 50, we know this distance is going to be 50 minus 36x. Because every hour he goes another 36 miles. And this distance here is just going to be 48x. So that means that the distance is going to be equal to the square root of 50 minus 36x squared plus 48x squared. Okay, so again, he starts out 50 miles east, so this whole distance here is 50 miles, and he's headed this way. So at some point, here's the little car speeding towards the intersection. Here's the other little car speeding away from the intersection. So we're tracking their distances apart as d. And this represents that distance. And we're trying to minimize that, so we want to take the derivative, set equals 0. Okay, so we're going to simplify this a little bit first. So then we'd have 50 times 36 and 36 times 50. So that would end up being 3600x plus 1296x squared plus 48 times 48 plus 2304x squared. So we could simplify that a little bit. So that'd be the square root of 2500 minus 3600x plus, so if we add those two together, 1296, we get, oh, interesting, 3600x squared. Okay, so then we take derivative. D prime is equal to 1/2 times negative 3600 plus 7200x all over all that stuff. 2500 minus 3600x plus 3600x squared. Set that equals 0. I guess we'll just have to set the top equal to 0. So that would be what? 7200 x is equal to 3600. So x is equal to 0.5. So that would be, how many hours will they be close to each other? It would be half an hour. Half hour. Okay, this one here is like the Elvis problem, if you remember. So the pipeline is to be run to resort. You can kind of see that familiar drawing. Pipeline is to be run to resort community, which is on an island 60 miles from the closest pipeline. At what point on the shoreline should the pipe turn into the water to minimize costs? There's the optimization. So minimize is the key. We need to write a cost equation. We'll call that x, which means this is, see how far is it? 30 miles. So this would be 30 minus x. So that means that the cost to run a pipe across land, $500 per mile to lay pipe through water, $300 per mile to lay pipe on land. So this is land right here, so that would be 300 times 30 minus x. Plus, and then the cost to run it across water is going to be 500 times something. And of course that is, let's see, that's 16. So this is going to be the square root of 16 squared, which is 256, plus x squared. Okay, so that would be in here 256 plus x squared to the 1/2 power. Sorry about that. Okay, so then we can multiply this out. So that'd be what? 9000 minus 300x. And we'll just have to leave that alone. 500 times 256 plus x squared to the 1/2 power. Take the derivative. C prime is equal, that disappears. That becomes negative 300. This becomes 250 times 256 minus x squared. A little extra line in there is. Oh, it's plus. Plus x squared to the negative 1/2 times 2x. Set it equal to 0. Move the 300 over. So now we have 500x on top and the square root of 256 plus x squared on the bottom and 300 over here. So if we multiply both sides by that, we get 500x is equal to 30. I'm sorry, that'd be 300. 300 times the square root of 256 plus x squared. Square both sides and we get 250,000 x squared is equal to 300 times 256 plus x squared. I'm sorry, 300 squared, which would be 90000. Okay, so what do we got? So we got 90,000 x squared and 250,000 x squared. So if I move that over to the other side, that would be 160,000 x squared is equal to, and that would be 90,000 times 256. So that would be 23,440,000. So I divide that by 160,000, 160, 123, and I get x squared is equal to 144, which means x is equal to 12. So what was the original question? Should the pipe turn into water? So that means you would go along the land for 18 miles, because x is 12, right? So you go along for 18 miles and then start heading out to the island. And then the second question says, what is the cost? Well, the total cost, you just plug 12 back into the total cost equation up here. And I'm not going to bother to do that right now. You can check that. Okay. Let's see. A pebble is thrown into the water and causes a circular ripple to spread across outward at a rate of 2 meters per second. Ooh, rate, probably related rates. Find the rate of change of the area of the circle. Okay. So we got these concentric circles growing. And we got the radius. So, and we know that, let's see, pebbles thrown in water causes a circular spread outward at a rate of 2 meters per second. So that means the radius, dr dt, is 2 meters per second. Find the rate of change of the area. So we want area is equal to pi r squared. 3 seconds later. So in my little ice box, we have 3 seconds here, which means the radius would be 6. Because in 3 seconds at 2 meters per second, it's going to get 6 meters, okay? So we take the derivative of both sides, we get dA dt is equal to 2 pi r dr dt. Plug in what we know. dA dt is equal to 2 pi times 6 times 2, that would be 6 meters, 2 meters per second. And meters times meters is meters squared, which is what we want. So we get dA dt is equal to 24 pi meters per second. All right, I think I'm going to pause it for now because this is getting long.